Hello guys, good morning and welcome to this video in my YouTube channel. So today I'm going to be solving the GCE 2024 Math Paper 2 question 9. The question reads, using a suitable substitution, show that the integral from 0 to 2 of x from the square root of 1 plus x squared dx is equals to 1/3 into 5 root 5 minus 1. Okay, so we're going to solve this question. Now the first thing to do is analyze the term in the bracket. They said we should use a suitable substitution, meaning that the substitution we are going to use, it should not disturb us a lot. First of all, whenever you see this square root function, make sure the substitution you use should be squared, so that the square root will also cancel the squared. So I will let this inner function to be equal to u squared, meaning that I will let 1 plus x squared to be equal to u squared. Now differentiating both sides, it will mean that the derivative of a constant is 0. So I have 2x dx is equals to 2u du. Now from there, you realize that 2 can cancel 2. So x dx is equals to u du, so that the integral from 0 to 2 of x is the square root of 1 plus x squared dx will now become the integral. Now I will not substitute the boundaries immediately. I will substitute the boundaries after, because the integral of, okay, you realize that x dx is the same as u du. Hope you are seeing it like me. So the square root of 1 plus x squared is the same as the square root of u squared, which is simply the square root of u squared, which is u. Now, so I will write there the square root of u squared. Now x dx is u du dot u du, which is equals to the integral of, now the square root of u squared is the same as u. Now u times u is u squared du. So what I have to integrate now is u squared du. But what's the integral of u squared du? We know very well that if you want to integrate a function raised to the power n, it is 1 divided by n plus 1, or raised to the power n plus 1. That function raised to the power n plus 1. So this one will be 1 divided by 2 plus 1 is 3 dot u raised to the power 2 plus 1, which is 3. Meaning that the integral of u squared du is equal to 1/3 u cubed. Okay, now we are still to substitute our limit, but before then, we know very well that we use the substitution u squared is equals to 1 plus x squared. Now, meaning that we are going to replace this u with its own function. Okay, it will mean that, but before then, I can write u cubed as 1/3 u squared dot u. Yeah, I think this is just algebra, which is equals to 1/3, but sorry. Who is u squared? 1/3 u squared was equals to 1 plus x squared. 1 plus x squared. Now who is u? Okay, since we had u squared to be equals to 1 plus x squared, it will mean that u is equals to the square root of 1 plus x squared. So I have the square root of 1 plus x squared. Now from there, I can now substitute my integral, my limit, boundaries of integration. It was from 0 to 2, which is equals to 1/3 I'll first start by substituting the upper boundaries. When I substitute the upper boundary here, I have 1 plus x squared. I have 1 plus 2 squared, the square root of 1 plus 2 squared, minus the lower boundary, minus, when I substitute 0 here, I have 1 plus 0 squared times the square root of 1 plus 0 squared. Okay, now which is equals to 1/3. Now 1 plus 2 squared is 5. I have 5. Now 1 plus 2 squared is still 5. Now the square root of 5 is root 5. So I have 5 root 5 minus, now this is 1 times 1, because the square root of 1 plus 0 is still 1. So I have minus 1. And our proof comes out as required, as 1/3 5 root 5 minus 1. 1/3 5 root 5 minus 1. Meaning that the integral from 0 to 2 of x times the square root of 1 plus x squared dx is equals to this. So you realize that the most tedious part was not even solving all of this. The most tedious part was to look for the best substitution. That's u squared is equals to 1 plus x squared. Actually, I could still set my u to be equals to 1 plus x squared. Yes, but just that it would have been very difficult for me to remove this square root. So that's why I just decided to let my u squared in such a way that this, the power 2 just cancel the square root. Okay, thank you guys for watching, and see you in the next video.